Now you can observe this. So lot of the actually physically you have to go and visit any industry here in Udyambag. Almost every industry has this type of a structure here. You can see this. You can see it has so many parts here. But for a designer to start with, you try to understand as minimum number of components as possible here, because it is too. You can see this. You should create, or else, I'll give you that. Or give you that video link also for this class. Now, if you see this particular 3D view of gantry girder, it is very difficult to understand what is what here. But observe, since for a beginner, what are the minimum things that you need to understand? You need to understand that much only. Let us try to understand. Now, where is the gantry girder here? What it does? What is the job of this? You can see this. So let us see this. Observe this. What is actually what is what here? So uh, in any industry, they have to shift heavy material, heavy box. Let us say the heavy box has it has come to the industry, and they want to shift it from one place to another place in the same hall only, from one end to the other end. It is very heavy, and every 10 seconds or every minute they have to lift those heavy bags boxes and place it at some other, all around this hall. They have to place it is a very heavy shipment. Okay, so how it is done, so the question is a very big box with a heavy weight has come. It has to be shifted inside means, let us say, some 50 to 100 feet inside it has to move. And in one day they are receiving 500 such boxes, heavy weight. Okay, then they have to place those boxes all around this room, one above the other, or like that. And how it is carried out. Only start with a simple question like this. The question here is, I have received some very big boxes. They are very heavy from the ship only. They have directly, you can say like that, and we are going to place all those boxes in this hall. Okay, so it is not like if I employ some 5-10 guys for this job, they will lift it and all. That is not possible here. So for this one, this entire arrangement is made. Okay, entire arrangement is for that, shifting heavy loads from one point to another point in a big hall, a big industry. You go to any industry in Udyamba, you will come across this. You just ask them, I want to see the gantry girder and all. It is always better actually to go and physically observe what is happening, how it works. Then only you can follow this operation and all properly. But I will make it simple here. Observe. I'll make this one simple. Now you can see here. Look at this simple front view of the front elevation. Now where is you can see this. Where is the gantry girder you observe here? Gantry girder, in this case, it is running perpendicular to this screen. This is the gantry girder. See this. So this gantry girder, if you have a close look at it, see this one. This is eye section, big heavy eye section, and a channel section is placed like this. This is what we are going to design. I have already given equal area axis. In one of the classes, I have solved a problem in which equal area axis was calculated. You can see the profile of this gantry girder is like this. There is one eye section. See, there can be different profiles. The best profile that is used is I section with channel section like this. Over that we can see rails. In case of trains, rails are there. No, that is here. That is rail is here. Over that one truss is attached. Okay. Now this is a crane girder. Try to understand the difference here. We are going to design the entry girder, but what is crane girder? You look at this diagram. Now I'll show you what is crane girder here. The elevation of crane girder I'm able to see here. See this one. So this is your crane girder. This is the crane girder. Now observe this one here. Let us say the weight is hanging here. The heavy weight is hanging here to this hook. So I will hang the heavy box here. I'll draw, the box is not shown, but I'll draw it here. So the box is connected like this. Heavy box it is. Okay. Even 10 guys cannot lift it. So this is so what now observe here. Now you look at this diagram like this. There is a gantry girder which is running perpendicular to the screen. This gantry girder profile is one I section and one channel section. On this gantry girder, crane girder is resting like this. So it moves. The direction of motion of this crane girder is along the length of the gantry girder. This is moving. I'll show you in plan. In plan, how it looks. Now what happens here is this is what we call it as a crab. What it does is it has wheels like this. So I can operate it in such a way that I can move this weight in the direction of x. So in plan how it looks, observe here. It is little bit complicated in the beginning to understand. Observe how it is working, how the object, how this weight is moving in x and y directions in plan. So I'll draw one diagram here. Observe this one. Simply I'll draw one plan of a industry like this. Okay, this is a plan of an industry, and a box is kept here, and let us say a box is kept here. Simply I'm showing like this. This is a box. This is a plan of an industry. Okay, this box I have to lift this box, or it may be outside also. I have to lift this box and I have to place it somewhere here. Let us say it is outside only, outside this. Okay, very simple thing I am telling right now. So I'll remove this one here. Okay, observe this one. A very simple way I'm telling. This box is outside, which is very heavy. I want to lift this box and place it here. Original here it is outside this hall or industry. I have to take it inside. This work is done by the arrangement in which gantry girder is there. Now what happens? You observe here. Now this arrangement is like that. See, first of all, this crane girder can move in this direction. See this. In which direction it can move? I'll show you here. It can move. It can move in this direction. This crane girder, which is resting on this rail, it can move in this direction now. Okay. Then this crab can move in x direction. See this. Okay. This can move in x direction. Are you able to follow this one? See this one. Now you see crab is it can travel on this crane girder like this. Are you following this? Like this, along this x direction, the crab can travel. because it is resting on the wheels. Okay, so this crab is capable of,
Sir, crab will go in the x-axis, no, right, sir?
yes, yes, yes.
Yes, that's what
Crab
I'm
is, see,
in this images. It's looking a bit confusion, sir.
no, no, I already told you that even after this 1 hour, you may not follow much. You may follow 30% unless actually you see that YouTube I have already given link.
Yeah, sir.
Okay, later you can check that one. Whatever is possible, try to understand in this class. Because
Yes, sir.
I told you know a gantry girder, once you understand what is happening there, how the heavy load is lifted and taken to some other place, as much as possible you try to understand right now. Now here,
Yes,
observe here. Now what is happening here is if I write y here, let us say this is y, this is x. Okay. Now this crane girder can move in y direction on this rail. Okay. You can see above this channel section rail is fixed, so it is just like a uh, railway track, rail it is. Okay, now this crane girder is supported on this. Crane girder itself can move along y direction because on either side it is supported. Crane girder is supported on either side at both the ends. I can move it in y direction along the length of the shop. Along the length of the shop, I can move the crane girder. Okay. At the same time, I can move weight in the x direction. That is, crab is doing that. So what will happen is now how it works. You see here. So first, I will lower this one. I will lower this one, and I'll see that I am just it is attached. So the weight is the box is attached to this crab now. Then what I will do? I will move this crane girder in the y direction. It starts moving along the on the perpendicular to the screen. It starts moving. Then it is taken somewhere here. Again, I'll adjust this crab. Crab starts moving now here because I want to place it here. So I will allow this crab. I'll make this crab to move in x direction so that exactly it is placed here. Okay. So this is how this thing is working. Okay. Any questions here? Very simple way of understanding is this. Don't see, don't worry about all those parts right now. That comes in the second hour. In the first hour, what is happening? See, all of you mute it. Mute it. Whatever quarrel is going on in your house, I can hear that. Somebody is quarreling there, and I can hear that one. So try to see all of you first mute it. So observe here. Very simple operation I am giving you. I have not given you any complicated part here. I'm just telling you one crane girder is there, one gantry girder is there. Crane girder can move along y line, along y axis. The whatever crab is resting on wheels on crane girder can move in the x direction. So entire system like this crab, this crane girder, all are resting on either side. There is one more. See, you can see here. There is the this one is there. No, here that is a crane girder. At the other end also crane girder is there. Don't get confused here. Other end. It is only 50% of the diagram is shown here. So for example, see this one. Whatever this part is there, no, just see this. Let us say this part, this is only 50%. Other end, see on the other side also one more crane girder is there. The I mean gantry girder is there. On that one, this crane girder is resting. What it means here is crane girder is resting on two gantry girders on either side, so that I can move it along the y direction. It means crane girder, if you look at this plan, crane girder moves along y axis, but it is supported on two gantry girders at the end. Okay. Now, as I told you, using this crane girder, I am moving the this one a box in y direction. Okay. Using this crab arrangement, crab and hook arrangement, I can move this weight on crane girder in the X direction. Like this crane girder is working. So this is how you need to understand here. Don't worry about this diagram in the beginning. Later you just sit quiet and check it. Best thing is you should go to the place, then check it. Once the design is completed, you go to any industry. Every industry is having this type of an arrangement. Lot of this one is there. Okay. So many, see, if you check gantry girder in Google with images, see this one, what I have done. Are you able to see this one? All of you? Just see this one here. Huh? Plate girder and see this. So this, see this link is, I have already given, YouTube link is given in the group. Okay. Only it is 3 minutes, nearly 3 to 4 minutes. He has given you the diagram of both plate girder and gantry girder. Only diagrams are given. Okay. That is one thing. Second is, if you search gantry girder in Google, see here, there are thousands of videos are there. But after my first watch my YouTube, whatever I'm explaining, which is according to VTU syllabus. Then you can, I'll give you some few more YouTube links. Now observe this figure. Are you able to see this one, this screen? All of you, are you able to see this Google screen here? Google gantry girder. Anyone of
Yes,
you
sir.
can? Okay. Now observe here. Observe this. You can see this diagram here. You can see this diagram. Now, what I am showing here is on the on your right side. On your right side, you can see black and white diagram is there. Components of a crane system. Now, where is the gantry girder? We can see again. Again, the profile is one I section and one channel section, and that channel section is supporting the rail. The rail is resting on channel section. Again, this channel has got this arrangement here. Don't worry about this connection between rail and the crane girder. That is very complicated. So for the time being, you don't worry about that. That is not there in the calculation also. Later you can physically check it. Okay. Now this is the arrangement is like this. Crane bridge or crane girder, trolley or crab, hook is there. Trolley can move in, as I told you, X direction. Okay. And the crane girder itself can move in the Y direction on the rails. Okay. Here in your syllabus, what is given is we are supposed to design this gantry girder. You can see this one. See, same arrangement is there at the other end. The other end of the crane girder, the same, again, one more gantry girder will be there, rail will be there. Everything is same on the other end also. It is only 50% of the diagram is shown here along longitudinal direction. Okay. So in your syllabus, see what is there. You have to design this part. That is how to design a gantry girder for all these loading arrangements. How to see, for example, since the this one is moving continuously, the trolley is moving in the X direction. What is the effect of that? How much load we should consider? How much percentage of weight of the hook and weight of this trolley or weight of this particular big heavy box which is to be lifted? What is the percent of that weight should be considered for this dynamic moment? Because it is continuously moving. Surge, it is called a surge load. So all those extra things will come in this design now, because the load is not stationary. Load is not stationary here. Load is moving continuously. For which position of the loads, maximum bending moment will be there. So it is all about your influence line diagram. We have studied in the analysis of determinate structures, influence line diagrams for bending moment, influence line diagram for reactions and shear forces. So that is you made use of in this particular problem. So influence line diagram means for what position of the loads there is a maximum bending moment at a particular point, because the loads are constantly moving. See, whatever we say WL square by 8 or whatever, our assumption is the load is not moving there. When I say WL square by 8, what it means? Static loads are there. When the loads are moving, we have to see corresponding to which position of the loads I will be getting maximum bending moment. So that has to be understood here. Huh? So it requires a lot of patience here. Huh? A lot of patience is required. Somebody's again started this one. You mute it. All of you, mute your mic, all of you. Okay, now let us go back to see what you do is see what you do is a lot of YouTube design is also there in this one. Don't go there, just observe the diagrams. Now one more diagram you see here. So this is the diagram which you can see here. That is a crane girder is supported on either side. On the right side of your screen, you can see right sides of the screen, gantry girder design basics they have given. This is the arrangement here. See this. Again, on either side, gantry girder is there. This is called as a bridge or a crane girder. Crane girder is again resting on the rails. Okay, weight of the rails must be considered while designing gantry girder. So on two gantry girders, the crane girder is resting. So this much is enough. Different profiles. The profiles can be different. I'll show you that one. That will come here. Again, on the right side, it will appear now. See here, universal beam. One can have this type of profile for gantry girder. Standard is this, very popular. Heavy gantry girder is universal beam and channel. See this. And a rail is there at the top. It means standard profile is this. That is why we are going to design whatever is standard profile. Okay. Any questions, anybody? Next is surge girder and walk away. This is different. Heavy gantry girder is still more heavy. So what we are designing here is only we are going to concentrate on this profile where one channel and eye sections are used. Okay. So these are the diagrams you can see here. Go to gantry girder or gantry girder in YouTube. You can check. I have already given one YouTube link. 3 minutes it is only. Design is there. Design links I will once my class is over. It takes 4 to 5 hours. After that, I will give you one more person's YouTube link. Only follow that one. There are hundreds of people have given the YouTube notes, but it is of no use for VTU syllabus. So you can see this one again, elevation, all this. Okay. This is roof truss. Again, see this roof clearance is there. So these are all presently, don't worry. Presently, minimum things you understand. Don't go for higher ends here. Simple things you learn. Okay. So let us go to the how the problem is given here. So is it clear this one what I'm telling? What is gantry girder? What is crane girder? All those things. Some more definitions are there before we can solve the problem. Let us see that. So this is the standard question paper example I have taken here. Observe this. Now you can see. Are you able to see this one? Gantry girder handwritten one. Gantry girder hand. Are you able to see this one? All of you?
Yes, sir.
Okay. Now see this design. This is a directly straight away question paper example here. As I told you, in case of steel structures, only 3 problems are there in your syllabus. One is trusses. One more is plate girder and gantry girder. Only 3 problems are there. Out of 3, 2 will be there in the examination. You have to decide which one to solve. So it is important for you to understand gantry girder also. You cannot say very rarely they are asking plate girder and gantry girder as 2 questions. Most of the cases what they are doing, there will be one truss with any one of the girders, gantry girder or plate girder, but sometimes they can do like that. So just observe this. Now here, design a gantry girder simply supported to carry a hand operated traveling crane. Again see here, power operated, that is there, that notes also I am giving. Hand operated he is telling here. hand operated traveling crane for the following data. So if it is operated remotely or with some system, some other system other than hand operated, some values will be different. That's all. No, there is no much change. If it is power operated, this in place of hand operated, power operated means some values will be slightly different. That's all. Nothing much is there. That I will explain it. So the span of the gantry girder is 6 meter. Now I'll go back. I'll go back. Span of gantry girder, he says 6 meter. What is that one? You can look at this diagram now. Gantry girder is here. When I say span 6 meter means I cannot see the span in this diagram because it is perpendicular to the screen here. It means whatever this profile is there now, that is a channel and eye section is there now, it is the length of this is 6 meter now. Span is 6 meter means that. Okay. So along y direction, you have to go. Along the y direction, the span is available for you. Span of gantry girder. Now span is 6 meter. Span of crane girder is 15 meter. Span of crane girder is 15 meter. Means this is 15 meter. That is this. If you look at this diagram here, whatever is enclosed in the red circle, no red circle, this one. This is crane girder. Thus, this span is more. But I'm not designing this one. I'm designing gantry girder. You can see here. Span of crane girder is 15 meter. It means I can move this crane girder maximum 6 meter here, in the y direction because span itself of crane gantry girder is 6 meter. It means your crane girder can move in the y direction maximum 6 meters only because span is this. Whereas the weight can move in x direction up to 10 to 12 meters, not 15 meters. I cannot say entire 15 meters. I'll tell you why. So if the span of crane girder is 15 meter, it means I can move the box in x direction up to 13 meters. Okay, let us say 3 meters or 2 meters less than that. Why it is, I'll tell you. Crane capacity is 200 kN. Crane capacity means how much load I can lift. Based on that only I have to design the crane girders, I mean the gantry girders. So capacity of the crane lifting capacity is 200 kilonewton. Self weight of the crane girder is given as 200 kN. See, both are same. Not every time, not every time. So crane capacity is 200. It can lift 200 kN. The self weight of the crane girder is given as 200 kN. Self weight of the trolley, whatever trolley is there, no, that that is 30 kilonewton is given. Minimum hook approach is 1 meter. Minimum hook approach. Now observe here. What it means, I'll show you in a simple way. Okay, just observe what is this minimum hook approach. You can see this minimum hook approach. Now, yours is a, let us say this is the elevation of a wall. This is the wall here, elevation. And the box is, I'll just show what is hook approach. I'll make you understand now. Just see this. This is the box which is being lifted up. Okay. Now your hook is coming somewhere here. This is your hook. Okay, like this. So when I say that hook approach is 1 meter means, see this box, see this distance is 1 meter now. Entire box, that is hook cannot reach. This hook cannot reach. Hook of this. Okay, I'll show you here. This hook cannot reach this point. Are you getting this point? There has to be some distance because the dimension of box is like that. Now, if I say hook approach as 1 meter, roughly what it means you just observe. It means when the hook has come this at this point, the box is touching the wall now. The box is touching the wall when the hook is, let us say, 1 meter. So if this is 1 meter, it cannot move beyond this point because the box is touching this wall now. Okay, that is what we call it as hook approach. In a simple way, I'm telling. Next is distance between the wheels 3.5 meter. This I will show you in the diagram only. Distance between wheels, just observe this. See, you can see the data is very less. Entire problem is framed in 4-5 lines. Distance between the wheels is 3.5 meter. Wheel base, it is called as wheel base. Self weight of rails 0.3 kN meter. This weight is also acting on the crane girder. Self weight of rails, I think you know it now. Whatever rail is here, no, this rail. See, on this channel section, rail is welded. See this green color inside I'm showing. Okay. This weight of this rail is also given in the problem because that is resting on the channel section. That is the load that has to be carried by the gantry girder only. So self weight of the rails is 0.3 kilonewton per meter. So this much is the data given. Okay. Now what is the data given? I'll repeat it. Observe here. Span of gantry girder is 6 meters. Span of crane girder is 15 meters. Crane capacity, how much load it can lift? 200 kN. Self weight of the crane girder itself is 200 kN. Self weight of the trolley which is running in X direction on the crane girder, that is self weight of the trolley, 30 kN. Minimum hook approach is 1 meter. Okay. Then distance between the wheels is 3.5 meter. Self weight of rails is 0.3 meter. You have to design with this much of information. So the data is not much. Okay. But the problem is a very lengthy problem. It is not. Now let us start with simple things first. Say step number 1 is determine the vertical forces. Now observe what I have done here. Step number 1 only I will be able to complete today. Observe it. Remaining I cannot do today. Step number 1, determine vertical forces. Self weight of the crane girder is given as 200 kN. Okay. Self weight per meter length is 200 by 15, which is 13.3. Span it is. For the entire span it was 200 kN. Per meter it is divided by 15, 13.3. Weight of the trolley or crab or trolley is one and the same, 30 kN. Then crane capacity, it has to, in addition to, it has to lift this much of weight, 200 kN. So you have to add this. Totally crane load is how much? Crane load is weight of the trolley plus whatever weight it is going to lift, 230 kN. So the crane is lifting, the crane is carrying a load of 230 kN because trolley itself is 30 kN and in addition to that it is lifting 200 kN. Hook approach is 1 meter. So with this much, I will draw a simple figure of crane girder. And drawing crane girder first. See this. Crane girder is 15 meter span. Hook approach is 1 meter. Now this is what is important. What is the meaning of hook approach? Because this weight cannot directly because of the box size and all, it is already touching the wall now. So that is 1 meter hook approach is given. So you can see this 230 is the point load acting and dead load of the crane girder is 13.3. How I got this? This is total weight of the crane girder was 200. Span is 15. So per 1 meter, how much is the load? 13.3. So 13.3 is the self weight of the crane girder per meter length. 13.3 into 15 is again 200, like that. Now just find out the, now once you understand this, it becomes a strength of material problem. Now there is UDL, there is a point load, determine maximum moment and maximum reactions and all that. That is what I have done here. See this, reaction is calculated. Now it is reduced to a simple problem of strength of materials. So reactions are there, one point load is there, one UDL is there. So in this way I have calculated the reaction sigma V is equal to 0 and sigma MB equal to 0. RA and RB are calculated. RA is more because point load is very close to RA, support A. So RA will be much more than RB. So RA is 314.71, RB is 115. Total load minus 314.7, 115. So this reaction is transferred to gantry girder through two wheels of trolley. Now what is happening is important. Once you calculate these reactions are calculated, okay, these reactions are transferred to the gantry girder. How it is? I'll show you the plan here. Just see. Now, what is important statement here is, which you may get confused, is this line. Only that much I'll cover and I'll take the attendance. This is what you should understand. Because this reaction calculation should not be a problem. It is a strength of material problem now. But what is happening, you observe here. This reaction is transferred to gantry girder through two wheels of trolley. Maximum wheel load on gantry girder, that is RA. Why? Out of RA and RB, RA is more. So I'll show that one, what is happening here. Now this is your gantry girder. This is also gantry girder in plan. This is your crane girder. Okay. Now I have placed the loads on the crane girder. One point load was there and UDL was there. Then I have calculated the reactions at A and B. Let us say this is A, this is B. You see this one, green line is crane girder, red lines are gantry girders. Now when you calculate the reaction at A and B, so reaction at A is nothing but that much of load the gantry girder has to carry now. Now for example, the reaction at A was 314.71. Reaction at B was 115. That is, the reaction at B is less, that is 11.5. That much of the point load means the reaction of crane girder will become point loads on gantry girder. So out of this, whichever is more, I should consider right now. More is RA. So that is RA is distributed on two wheels. Now what happens here is, how it is done. Now I'll draw one more figure here. Just observe this. No, actually, I have to show this line now because the wheels are resting on the crane girder. Now, what is happening here is this RA is distributed. Let us imagine that this wheel is coming on this particular 2 points here. These are the wheel positions when it reaches this point. And hook is at the center. Hook is at the center. But wheels are resting. These two wheels of this tram are resting here. Okay.
Excuse me, sir.
Yeah, tell me.
Sir, array is wrong, sir.
Array is wrong. Check. Just check it. Check it.
Sir, equation is wrong. Minus 230 into 14.
Okay. Let me check it. Let me check it again. RA into 15 is correct.
Yes, sir.
Okay. RA into 15 is correct. Moment about B. 230 into
14.
230 into
14.
Yes, yes, you're right. You're right. So this is, you mean to say, instead of 1, it should be
14, sir.
Yeah, you're right. What about the next one? Third term?
Sir, it is correct, sir.
That is correct. Now you tell me what is this value?
Sir, value is correct, sir.
Means while writing, I forgot to write 4 here, I think. I should have written 4, that's all. Correct?
Yes, sir.
Are you okay? Say this.
Yes, sir.
Instead of 1, I should write 1, 4, and the answer is no problem. It is correct only. Is it all right?
Yes, sir.
Okay. It means there is no problem with the final answer, no? Final answer is correct. 314.71. I forgot to write 4 here, I think. It is 14 because
Yes, sir.
moment is
Final
taken
answer
about
is
B.
correct, sir.
Okay, moment is taken about B. I should write 4. That's all here. Answer is correct. No problem. No problem. You're right. So see here, observe now. Now exactly what is the meaning of this you should understand here. Because strength of material is over when you calculate the reactions. You are back to steel structures now. This reaction is transferred to gantry girder through 2 wheels of a trolley. Okay, that is, now imagine there are 4 wheels are there for this trolley. Out of that, 2 wheels are now resting on the gantry girder. Okay, now RA is distributed on 2 wheels. Whatever reaction is there, no reaction is there 314.71. It is distributed equally on the 2 wheels, which is 157.35. So this is how I got 2 point loads. Now 2 point loads separated by the distance between these 2 wheels actually. That is what there was a confusion here. So I need to find out distance between these 2 wheels. Okay, means it has to be given actually. They have to give that value anyway. So what happens here is each wheel is acting as a point load carrying 157.35 service load, which is multiplied by 1.5, 236.02. Now on this gantry girder, there are 2 point loads. Where to place them, it is my problem. Whether I should place at the middle, at the other end, or this end, near the supports. I have 6-meter span. In this 6-meter span, where I should place these 2 point loads, each is 236.02. But distance between these 2 point loads is fixed. I cannot change because it is distance between the wheels. Together I can place them anywhere depending upon influence line diagrams. Okay, that is what you need to understand here is at the end of this particular slide is I am having 2 point loads. The distance between the 2 point loads is fixed, but I can place them anywhere. Keeping the distance between them same, I can place them anywhere because this crane girder is moving along the red line. Crane girder moves along the red line. That is, red line is gantry girder. So these 2 point loads can be anywhere depending upon the new position of your weight to be lifted, box to be lifted. Anywhere it can be there, no? It can be anywhere. These 2 point loads can be anywhere on the red line. That I have to decide for which position there will be maximum bending moment in the gantry girder. So let us go to the next line here. So I think up to this, any doubts are there? Because I'm going to stop now. I have just done one step. Only one step is done. Remember one thing here. Till now, I don't know where to place these 2 point loads to get maximum bending moment in gantry girder. You cannot say that I will place it at the center. Maybe that may be correct also, but right now we cannot say like that. Exactly, I'll find the midpoint of the span, that is 3 meter. So these 2 point loads will be kept on either side of the midpoint of the span. That is one possibility. But let us see that one. It means you should be good in influence line diagrams beyond this point. Okay. So this is the one thing here. I think this up to this there is no confusion because even though the gantry girder and all arrangement is very complicated, you have to physically go to the site and check it. But as far as problem is concerned, I'm trying to make it a simple strength of material problem only. Okay, with the given data. With given data. So let us go to the next page. So this is the second page here. Now you look at this step number 2, vertical bending moment. There will be horizontal bending moment also later. There will be horizontal forces. Right now, look at vertical bending. Now, how to find vertical bending moment? Now, what I have done is I have drawn this. I have drawn this 6-meter span now. Now here it is gantry girder. This is gantry girder. Previous one was crane girder. See this. 15-meter. I have found out the reactions. I have transferred the reactions on 2 wheels at the end of this step. That is I am showing you on the gantry girder. See this. Wheels are separated by 3.5 meters. Okay. So distance between two rear wheels, backside wheels, the distance between those two wheels is 3.5 meter, which is given in the problem. Distance between one front and one back wheel of the trolley is not given in the problem. It may be 3.5 only. We don't know that. They have given distance between the center to center distance between the two rear wheels is given. Are you following what I'm telling? I'll show it. Observe this small diagram I'll draw here. See, this is the trolley which is moving. This is one wheel is here. On one more side, one more wheel is there. Here is one more wheel. Here is one more wheel. Just rough diagram it is. And it is trying to move in this direction on crane girder. So distance between, I think already it is clear to you. This distance is 3.5. Whatever red color is there now, this distance is 3.5. So 3.5 is given. Reactions are distributed on these two wheels. Just give me 1 second. I'll just connect this. Okay. So this is a observe here. Today let us complete it. Let us do this only this part now. And placing the load, observe here how it is placed for ILD. So what I have done here is vertical moment I have to calculate. Vertical bending moment has to be calculated now due to gravity loads. Bending moment due to live load. Whatever is the live load I have to calculate, plus bending moment due to impact. Impact means continuously the crane is the crane gird is moving, actually continuously it is moving. Then bending moment due to dead load. All these together I'll get maximum vertical bending moment. Now what I have done here is maximum bending moment under second point load occurs. There are 2 point loads as per your analysis of determinate structures influence line diagram. It is maximum bending moment under second point load occurs when centroid of these two loads and midpoint of the span are equidistant from the second point load. So you need to read this one 2-3 times. Once you may not follow it, you read this particular statement, which is taken from influence line diagram chapter of 4th semester. To understand this one, you need to read 2-3 times here. Maximum bending moment under second point load occurs when centroid of loads and midpoint. Now, what is the centroid of loads here? Because both are same loads, centroid is exactly 3.5 by 2. What is that 3.5 by 2? 3.5 by 2 is the centroid of loads. Okay, that point and midpoint of the span. Midpoint of the span is 3 meter. Okay, you are having 2 points now. One is 3.5 by 2. Where to place the midpoint you observe. Where to place the midpoint of the loads you understand from this, or equidistant from the second point load. What it means here is, now you look at this one here. Let us divide 3.5 into two parts, which is 1.75. Okay, now 1.75 is here. What has happened, you observe here. 1.75 is here now. Okay, which is the midpoint of 3.5. That is centroid of loads. It is red line is centroid of loads is equidistant from the second point load. Midpoint of the span. Now observe this. This point, this one is 3 meter from A because it is a midpoint of the span. This red line is midpoint of the loads. Red is midpoint of the loads. Green is midpoint of the span. Now these two are equidistant from the second point load. What is that second point load? Second point load is here. Now look at this one. Second point load is this one. It is equidistant. See this. midpoint of the span, that is this one, 0.875, 0.875. In this way, you should place the loads. It means you cannot place these 2-point loads anywhere on this span. You cannot say I'll place it here, one on the support, one more at 3.5 meter, because I cannot adjust 3.5 meter. It is fixed. Now, what my job here is where to place these 2-point loads so that I am getting maximum bending. So this is what is done. Every time you have to do like this only. Now, how it is done? Observe here. First, what I will do, I'll mark the midpoint. I'll mark the midpoint. Let us say green point. Green is midpoint. Simply, you don't worry about anything. Draw the 6-meter line. How to start this one is draw the 6-meter span. Mark the green point. That is midpoint. 3 meters. Totally 6 meters. Then what you should do? Divide 1.75 two times. Means this by 2 you can make. Are you getting this? That is 3.5 divided by 4 you make it. How to draw this I am telling. That is draw this 6-meter line, mark green point, then distance between the wheels divided by 4 you make it. That much should be there here, 0.875 this side, 0.875 this side. Observe here what I will do. After this I am going to close it. I'll take attendance. How I am going to draw as a beginner. As a beginner, what I will do, observe here. I'll just draw this 6-meter. Okay. I have 2-point loads and my job is to keep them at appropriate locations. One is here, one more is here. They are separated by 3 point, separated by, sorry, this is 3.5 meter horizontal distance. It is fixed. I cannot change it. Okay, this much is given. Now what I will do, I'll mark the midpoint like this. I'll mark the midpoint like this. I'm going to place, see this one. As a beginner, what I'm doing, I'll tell you. I'm going to place 2-point loads. These are the 2-point loads. Distance between them is fixed. I'll place the front load, front one. Here. I'm going to place it here. Now, what will be this distance? This distance will be 3.5 by 4. Okay. Then from this one, you can easily put one more, that is 3.5 meter distance, like this. So if you do this one, it is all right now. That is what is done here. See this 0.875, 0.875. Okay. Like this, you have to place and find out the sigma. Again, use the simple strength of material to calculate bending moment and shear force values. Okay. It means once you know how to place these 2-point loads to get maximum BM and SF, that is enough. Rest all is again strength of material problem. It is. See this. Simply you are giving a problem. If I give this problem to any 3rd semester student, he will solve it. I don't have to tell what I have done. I'll be just giving this problem. That's all. These are the point load. These are the distances. Give me shear force and bending moment and reactions. So this is the end of your second step. But I'll continue this second step only. I'll continue up to any questions.
ನಿನ್ ಫೋನ್ ಖಾಲಿ ಐತಿ
See, you can mute it. You can mute it because what is happening in your house also I can hear. See, bending moment due to live load, bending moment due to impact load, bending moment due to dead load. That is all calculated. Now, bending moment due to impact load. So there is a code book for that. It is very lengthy, but in this subject, either you have to just fix it as 10 to 20%. 10 to 20% of maximum bending moment. I have taken 20% here. 20% means on the higher side I have taken. I can choose even 10%, but 20% of the maximum bending moment is taken. What it means, observe here. What it means. Bending moment due to the loads is calculated. Bending moment due to impact load is calculated separately. Bending moment due to dead load has to be calculated separately. Live load is done already. Live load is done. Now, bending moment due to impact load is 20% of 355.25. Now, bending moment due to dead load of gantry girder. See this. There are 3 parts here. Due to live load, that is already calculated. 236.02 here, 236.02. They are placed at appropriate locations, and that is all live load. It is live load bending moment. Impact bending moment due to impact, because continuously the loads are moving. Crane girder itself is moving. On crane girder, the trolley is also moving. That is why there will be an impact due to this, which is 20% of bending moment due to live load. So these two are calculated. BM due to dead load of the gantry girder I have to calculate. Gantry girder. You have to assume something here. Assume dead load of gantry girder 2 kN per meter. This is a completely approximate. This one you have to assume in the examination without fail. That is GG means gantry girder. Assume dead load of gantry girder
Sir,
2
if they are
kN per
not,
meter.
sir, if they are not given, you have to take the 2 kilonewton per meter as the.
Yes. Usually it is not given only. You can
Time's up,
start
sir.
with
We
Time's
have
up.
to take it
no, no. You
2
can start
kilonewton
with
per meter as
2 kN per
the.
meter.
Fine, sir. Fine.
Okay, because after designing, if you try to after designing everything, if you try to find out the dead load, it will be very close to 2 kN only. It is by experience only. This load is by experience. If I choose, for example, one channel and one angle, that is one I section and one channel section. If I place them, so as I told you, the profile is like this. The profile of a gantry girder will be like this. Like this, one I section and one channel is there. Now if you find out the weight of these two per meter length, it will be very close to dead weight of these two, it will be very close to 2 kN per meter, along with the rail also. It is approximate. It is approximate. If the value is too high after the design, you have to revise it actually, but to start with, it is 2 kN per meter. So this has to
Sir,
be
it should
covered.
be minimum less than 2, or it should be more than 2, sir, or it should be exactly 2.
No. What will happen is, see, after the design is over, you can check, because you'll be having the sections finalized. For those sections, steel tables weight will be given. So weight of the channel per meter will be given, weight of the angle per, I section per, add these two. After adding these two, if it is more than 2 kN, much more. If it is 3 kN also, no need to revise it. If it crosses 3 kN, 4 kN, 5 kN, like that, if you start getting it, then you may have to revise the section.
Redesign the steps.
Yes, you have to redesign it, but that is not going to happen usually. You will see that one. So dead load. So total load is equal to dead load of the gantry girder, weight of the rails. What is weight of the rails here? Weight of the rails means there is one more section is there, no? Here, like this. On this one, this one is supported. Gantry girder is supported like this. Okay, so it means dead weight of gantry girder plus weight of this rail, green color whatever rail is there, no? That is because that is going to be supported on that. It is taken, it is given, I think in the problem it is given as 0.3. Weight of rails is given as 0.3 in the problem itself. If you want, I'll show that one. I think it is given. See this last line, self weight of the rails is 0.3 kN. So weight of the rail is given. This green whatever I have shown here, okay, that weight is already given in the problem. Okay, you have to add that also. This weight of this rail is given, whereas since I don't know the profile right now, I don't know what is the dimension of channel and I sections, I have taken it as 2 kN. So 2 plus 0.3, 2.3, then factored is 1.5 times this, 3.45. So it is simply it is UDL now. UDL on 6 meter span. So dead load of gantry girder is 1.5 times 2.3, 3.45. 3.45 includes weight of channel, weight of I, and weight of the rail per meter length. Okay, that is, you can see here. Now observe this diagram. Simply WL square by 8. Because it is UDL for a span of 6 meter, UDL it is 3.45 into 6 square by 8. So all the three values I have calculated. Factored vertical bending moment, MZV, MZV. Superscript is V means vertical moment. It is 355.25, 20% of this is 71.05, then WL square by 8 is 15.52. Total is 441.82 is the bending. Then vertical shear force has to be calculated. Now you can see for vertical shear force, the position is changed. Because if I keep the same position of point loads, I'm not getting maximum shear force. Again, I have to go for influence line diagram for shear force. For this one wheel should be directly on support C, on support C here. CD. AB is the span for crane girder. CD is the span for gantry girder. So directly one point load should be resting on C. One more is at a distance of 3.5 meter. Like this, it should be placed for finding vertical shear force. Remember that the position of those two point loads are not same for bending moment and shear force calculations. Whichever is giving me maximum shear force, that way I should